Okay, we are here for video 3 in OLI Mod 24 guide. So when we last spoke, maybe just a few minutes ago, I had brought up the fact that having a population standard deviation is not always realistic, which leads us to William Gossett and the search for better beer. So I've put this link in your Canvas module so you can take a look through. So he was the head brewer of the Guinness Brewery in Dublin, Ireland. He lived late 1800s to early 1900s. So, and he joined Guinness in 1899, as it says here. Um, so he was involved in experiments using statistics to understand his data and to try and make better beer. But Gossett faced the problem. We noted in using the Z distribution, he didn't know the population standard deviation because, of course, Guinness Brewery is not going to, have him use all of the beer for his research. Then they don't have any beer to sell and keep their company going. So no population standard deviation can be known. Further, he noticed that replacing sigma, which would be our population standard deviation, by the sample standard deviation, S. So remember, those are our symbols. Sigma is a population standard deviation. Sample standard deviation is S. So if he just does that in the z-score formula and calling the result roughly normal wasn't good enough, okay? So when we're dealing with proportions, p hat is a fine substitute for P. That is a good unbiased estimator. And when we use X bar as our substitute for mu in terms of using a sample mean to estimate a population mean, that is again a good unbiased estimator. But trying to use a sample standard deviation, S, to estimate or replace a population standard deviation, sigma, just does not give results that are good enough. So instead, he developed what is now called the T distribution. Before I go on, why is it called the T distribution? Well, as is the case with many companies, Guinness allowed Gossett to publish his statistical discoveries, but not under his own name. So he published under the pseudonym Students T Distribution, which is now what we call it. And here is the T distribution. So the first thing you're going to say is, well, that looks just like our normal distribution. And it's true. It has a smooth, symmetric, bell-shaped curve. So the shape is still the same. This DF thing here is talking about degrees of freedom. And degrees of freedom is related to sample size. In this application, it's actually your sample size minus 1. And just to give you quick understanding of that, suppose I have 3 pens and I'm going to hand them out to 3 people. So I have choice or freedom in the pen I give to the first person. I have 3 pens I can choose. The second person, I still have some choice. I still have some freedom. I've got 2 pens left to choose from. I hand that pen out. But for the third person, there is no choice. There is no freedom left. That person gets the pen that I had. So I had a sample size of 3, but I only had freedom to assign 2 pens. So that's how degrees of freedom is related to sample size in this case. And you can see that there are different curves depending on the degrees of freedom. So for the smallest degree of freedom, the smallest sample size, the curve is shorter and fatter, indicating that it has more variation among those sample means, because we're still looking at this to be our distribution of sample means. As our degrees of freedom increase, the curve gets taller, the curve gets skinnier, indicating that there is less variation. Now notice this blue curve is degrees of freedom 5, and then this black curve is really limitless degrees of freedom. So you can see that very quickly the curve reaches its sort of full potential in terms of how tall it can get, how skinny it can get. But sometimes, you know, even small variations will make a very big impact. If you're looking at you know, the mean amount of active ingredient you're going to put in your drug so that you don't kill people, you're going to need a very, very small margin of error there. And so it's critical that you have exactly the right curve you're looking for. All right, so I'm going to go back into what's on our guide now, and this I've taken out of OLI. So in this model now, the dotted line is a normal curve. So you can see that really once the degrees of freedom get up around 15, we are very closely resembling a normal curve. And again, the infinite degrees of freedom over here would be just that much closer to this normal curve. The T curve never gets taller or skinnier than the normal curve does. So similarities, bell-shaped distribution, central peak. This centered at 0. So that is the center, you know, for the normal curve. If we're talking about z-scores, then it's very small here, but this is the center of 1, and then z-scores of 1, 2, 3, -1, -2, -3. If we were talking about the t distribution, then the correlation is a t-score. And the t-scores then go 0, 1, 2, 3, -1, -2, -3. But a t-score tells us exactly what a z-score does. It tells us number of standard deviations from center. So again, a positive t-score, you're above the mean. A negative t-score, you're below the mean. If you're at a t-score of 2, you know that you are 2 standard deviations above the mean. Down the bottom here, when is this T model a good fit for the sampling distribution of sample means for our SDSM? I'm going to go to the second bullet point first. We use the T model if variable values are normally distributed in the population. If this is not true, then make sure the sample size is large, more than 30. So exactly the same criteria to use a T distribution as to use a normal distribution. Then when do we pick T instead of Z? Use the T model if sigma, the population standard deviation, is unknown. If sigma is known, then we use the normal model instead of the T model. So the criteria for making a for making a confidence interval about means is the same to use Z and T. Either your sample size is bigger than 30 or your population has a normal distribution. If you have your population standard deviation sigma, you use the normal distribution, and in StatCrunch, you choose Z-stats. If the population standard deviation is, oops, sorry, let me go back. I was writing in the wrong place there. All right, do over. Okay. If sigma is known, then we're using the normal distribution, and in StatCrunch, we go to Z stats. If the population standard deviation is unknown, that's when we're using the T model, and in StatCrunch, we are picking T-stats. So let's put that in action here for number 3. This is going along with a Learn by Doing activity on page 159. So according to the website, collegedrinkingprevention.gov, about 25% of college students report academic consequences of their drinking, including missing class, falling behind, doing poorly on exams or papers, and receiving lower grades overall. So this first, this is a proportion. So if we were coming to this on a test, we might be thinking right now this is about proportions, but let's keep reading. A statistics student is curious about drinking habits of students at his college. He wants to estimate the mean number of alcoholic drinks consumed each week by students at his college. Okay, so now we know that we're dealing with means. He wants to use a 90% confidence interval. He surveys a random sample of 71 students. So that is our sample size, 71. And because his sample size is bigger than 30, we know that we have a normal or a t-distribution, whichever one we need. The sample mean is 3.93 alcoholic drinks per week. So that's our X bar value. That is the value that's going to be right here at the center of our confidence interval. The sample standard deviation is 3.78. Okay, so all we have is the sample standard deviation, S. It's 3.78. So we're going to use the t-distribution because we do not have the population standard deviation sigma. So let's go over to StatCrunch. We're picking stat and then T-stats. We have one sample and we only have a summary of that sample. Our sample mean is 3.93. Our sample standard deviation is 3.78. Our sample size is 71. Confidence interval with a confidence level of 0.9. Compute. All right. Now, we have not talked about how to calculate this standard error in the t-distribution, right? It's not sigma over the square root of n. That was for the normal distribution, but we don't have sigma. So we're just going to be happy that StatCrunch gave us this standard error. All right, so our lower limit is 3.18 and our upper limit is 4.68. And so that is our 90% confidence interval estimate for the mean number of alcoholic drinks consumed each week by students at this researchers' college.